Good morning, everyone. Today, we are going to discuss about what is electronics and what is voltage, current, and resistance, and what is the relationship between these three. And also, finally, we are going to end up with what is the difference between AC and DC. So, this is the first lecture series in the analog electronic circuits. Come, let's get into the topic. So let's start with electronics. So what is electronics? So as we are dealing with analog electronic circuits, to know about electronics is very essential thing. So because this is the fundamental one, without knowing this, what is electronics, the other things, the advanced techniques and methods and all studying those things and all, it is useless. So first thing, let us start with electronics. So what is electronics? So electronics is the branch of science that deals with study of flow of electrons. That is the simple term about electronics. So that means that study of flow and control of electrons. So the flow of electrons, which is called as a current, that is called as a electricity, and study their behavior and effects in vacuums, gases, and semiconductors with the devices using such as electrons. So this is called a definition for the electronics. So simply we can call this electronics is nothing but of study of flow of electrons and control of electrons. So what is electrons actually? So electron is nothing but of one of the in any material if you take that consists of many atoms, many tiny atoms. So each atom will consist of a nucleus that consists of proton and neutron, and we have yeah, the electrons will be there. The electrons will be rotating in the orbit outside of the atom. So that electron is a negatively charged particle. So this is called an electron. So this control of electron is accomplished by devices, that is electronic components that resist, carry, select, steer, switch, store, manipulate, and exploit in the electronics. So what is voltage, current, and resistance? So what is voltage? So voltage is nothing but of is the difference in the electric potential between 2 points. And current, which is nothing but of I told you already, the flow of electrons is called a current. And the resistance. So resistance is nothing but of the measure of opposition to the current flow in an electrical circuit is called a resistance. So this is your definition for these terms. So to easy understanding, we have an analogy in the left side of the slide. So we just assume on a water hose there some if you assume that is some water is flowing inside the water hose, that pressure of the water is nothing but of considered as a voltage, and based on the size of the hose, the water flow will take place. So that is assumed as a current. And the resistance is if you pour some sand, if you keep some sand inside the hose, that will resist some flow of the water. So this is considered as a resistance. So the sand resists the flow of water. So same thing, the resistance in the conductor will resist the flow of electrons. That means it controls the current. So this is the simple analogy to understand the voltage, current, and resistance. And the unit of these three parameters are voltage. For the voltage, that is called volts, that is V, and current, amps or ampere, and for resistance, that is ohm. So that symbols and all that is given here. And you can see in even more simple example is given in the slide. See, volt is pushing in on path, right? But the ohm is on all outside of the that part, that is holding, that is resisting the amp. That is amp is nothing but of considered as a current. So this image which clearly depicts the relationship between voltage, current, and resistance. And if you see this diagram, that is voltage and current, see, you take one copper wire. So if you take one copper wire, one end of the copper wire will be assumed as a negative, and another one point is assumed as a positive. If you assume like this, the difference between these 2 points will be considered as the voltage. It's called a potential difference. So I told you already the potential difference is nothing but a voltage. And between these, there is some electron movement inside the copper wire. The electron movement, which is considered as a current. So the current is considered as the current unit of the current is ampere. So this is the image which clearly explains the difference between voltage and current. And one more example for voltage and current, if you fire if you fire by using your matchstick, you will see the fire, right? Because of the fire, you will feel the heat. So here the fire is assumed as a voltage, and the heat will be assumed as a current. Because of the fire, you will feel the heat, right? So because of the voltage, you feel we are witnessing the current in the conductor. So that's just, one more analogy to understand the difference between voltage and current. And coming to the next thing, there is a AC and DC. So obviously we know what is an AC, that is alternate current and direct current. So what are they? So in the slide you can see alternate current is mentioned the above, and direct current is mentioned the below to the AC. So alternate current is nothing but it has a two positive and negative flowing will be there. Positive and negative electron movement will be there. So that is given in this diagram. That is a graphical representation. Whereas in the DC direct current, the electron movement will take place in only in one direction. This is called a DC. That's a direct current. So why it is called as an alternate current means since we have a positive and negative movement of the electrons in both directions, so it is called as an alternate current. So since the current movement will be takes place in only one direction, this DC is called a direct current. And why we have this kind of AC and DC means that we will be studying in the forthcoming topics. But simply, this is used to in our if you see uh, in our home, we are using many components: mobile phone, laptop, computers, TV, light, fan, so etc. So some of the components which requires AC, and some of the components which requires DC. So accordingly, the based on the application, either AC or DC can be used for our daily purpose. So in the next session, we will see the another topic. So thanks for watching my video. Thank you.